Good afternoon, everyone. We are Group 2, presenting our semester project, Diet Tracker, Calculate Calories, Be Healthy. The idea grew from something simple we all experience, trying to eat better but not having a tool that's actually simple to use. We target people who care about health but lack the time to record every meal, college students balancing classes, working professionals juggling schedules, and even families looking for lightweight accountability. Most existing calorie tracking apps overwhelm users with pop-ups or premium tiers. We wanted to reimagine the experience, an open clutter-free web app that anyone can access instantly on any device. Today, people are more aware of fitness, yet less consistent in self-tracking. Manually calculating calories or portion sizes discourages long-term use. Furthermore, privacy concerns arise. Many nutrition apps collect personal health data for advertising. Our goal became eliminating all three by creating a system that is frictionless, precise enough for daily guidance, and transparent in how it handles data. Our solution is a web-based, intelligent food logging system. Users can sign in securely with Google Auth, input food information, or even upload images for AI-driven calorie estimation. The app automatically summarizes calories, micronutrients, and daily targets. We prioritize clarity over complexity. Each string has a single purpose: food logs, view total, or update profile. Behind that simplicity lies a structured architecture that ensures reliability and scalability.
So hi everyone, this is Kushal. So on this slide, we are presenting our system design, which is shown in two main diagrams. So on the left, it is the architecture diagram. Now on the left, we have the architecture diagram, and that diagram zooms inside the Rails application box from the first chart. It shows our primary design pattern, model view controller, and MVC. You can see how a request flows. It comes from the browser into the web layer, our router, which sends it to a controller. The controller acts as the manager talking to the models in our domain layer, which is the brain of our app, and the views in our presentation layer, which renders the HTML. We also made a major design choice to explicitly separate authentication into its own auth layer. This keeps our main controllers clean and makes the system more secure and maintainable. So on the right, we have the system diagram. This is the high level bird's eye view of our entire infrastructure. So you can see the client's browser at the top, which makes requests to our hosting environment on Heroku. Our Rails application running on a Puma server is the core. It connects to our storage layer, which is a PostgreSQL database. The app also connects to external services for key features like Google for authentication and an AI service for image and ML analysis. So we are using ChatGPT here. Finally, our CI/CD pipelines uses GitHub Action to automatically test and deploy our code. This diagram covers our main frameworks and tools, which is Ruby on Rails, Heroku, Postgre, and GitHub Actions. So on the second slide, we are diving deeper into the data and the domain layers we just saw. So database schema, it is on the left side. So this is the blueprint of our production PostgreSQL database. This diagram identifies our major system design choice to keep the database simple and normalized. It's built on just two core tables, which is users and food logs. The food logs table has a user underscore ID foreign key, which creates a classic one-to-many relationship, and one user can have many food logs. Now, on the right, we have the class diagram. So this shows how the database schema is represented in our Rails application code. The diagram directly represents the M or model in our MVC design pattern. You can see the user class and the food log class, which correspond directly to the database tables. This illustrates another key design choice, the separation of concerns. All our business logic, like the methods to calculate goals or find remaining macros, lives inside these models. This keeps our controllers clean and makes our application much easier to test and maintain. Okay, so this slide shows our complete tech stack, which covers all the frameworks and tools we use to build the application. So for our core framework, we use Ruby on Rails. We choose to justify our design as a convention of a configuration principle followed us to allow us to build a secure app very quickly. And for the language, we use Ruby. For the database, we use SQLite in development because it's simple, and PostgreSQL in production, and Heroku because it's powerful and scalable. For testing, we use Aspect for unit test and Cucumber and acceptance, and Simple Cove to ensure we hit 100% test coverage. For CI/CD, we use GitHub Actions to automatically run our tests and deploy the app. For deployment, the application is hosted on Heroku. And finally, for AI integration, we use the OpenAI Vision API to handle our image analysis. Now, the final slice covers our design patterns and justifies the major system design choices we made. The primary design pattern we used was MVC, with model view controller. We justified this choice because it enforces a separation of concerns. So it keeps our logic in the models, our requests in the controller, and our HTML in the views. This made the application organized, scalable, and easy to test. We also made several other major design choices like the monolithic app. We chose to build a monolithic app instead of using microservices. We justified this because it's much faster to develop, simpler to deploy, and perfect for a project of our scale. Now, Google OAuth, we justify like using Google for authentication because it completely avoids the massive security risk and liability of storing user passwords ourselves. And now we have SQLite versus Postgres. So finally, we justify using two different databases. We use SQLite in development because it requires zero setup, making it fast for local testing. But we use PostgreSQL in production because it's powerful, secure, and the standard for scalable application on Heroku. This code decisions were the foundation of our project and allowed us to build a secure, testable, and robust application.
Here's our user interface overview. As you can tell, you have the ability to sign into our calorie counter with Google. From there, we'll ask you about what's your username, what's your gender, date of birth, and a bunch of other things so that you basically have the ability to get your BMI calculated so that you know the amount of calories, protein, fats, and carbs that you have left within the day. From there, you now have the ability to add foods to your daily intake, where you can either manually fill out the information for each food, or you can automatically get the food filled out by taking a picture of it and then having ChatGPT analyze it for you. Once you're back on the dashboard page, you also have the ability to check your food logs of previous foods that you've added, and you can edit them or delete them at your choice. Here's our low fidelity mockup. Basically from here, we started with a very low tech drawing where basically this shows the flow from our login to the dashboard. After team feedback, we translated this into Figma wireframes and then ended up finalizing some of the layouts and colors. The front end was implemented using ERB templates and custom CSS style sheets rather than Bootstrap, mainly because we wanted something that was easily customizable to what we were building. We also used flexboxes in our CSS, and we also used percentages to basically allow for you to use it on multiple devices, like your computer versus your phone or tablet. Here are our design principles in action. Our first design principle is responsiveness, which is basically the idea that whenever a user presses a button, our app quickly responds back to the user in timely fashion. Our second design principle is consistency, which is the idea that whenever a user does query for something, that our app consistently provides the correct response back to the user. Lastly, we have accessibility, which is the idea that our app is very accessible in terms of our button layouts and that you should be able to access our app no matter what device that you're using. Here are some of our major UI choices. First, we have our navigation on the top. As you can tell, you could go to the dashboard, the food logs, you can even relook at the survey or sign out. We also have inline error messages to encourage clean data entries. We have custom CSS, which reduces our dependencies like Bootstrap and achieves fast load times even on slow connections. And we also have flash feedback, which is basically the idea that we have immediate visual responses that reinforce our users' confidence. We also have a minimalistic color scheme, as you can tell with the blue and white that we have. AI tools and development. So we didn't just actually use GPT and Copilot to help us code, but we actually also implemented GPT in our query to add food entries to our daily foods. In that whenever you take a picture of a food and you choose to not fill out any of the macros and calories of the food, GPT will automatically attempt to give you the best estimate of what the calories and macros that you should have from that food and decrement it from your daily calories. We encountered three major challenges. First was managing our environment variables for OAuth on Heroku. We solved that through encrypted environment variables. Number two was resolving merge conflicts in view templates. We established naming conventions to help prevent overlap on this. And lastly, we balanced simplicity and functionality, which helped us learn to remove unnecessary features to maintain focus. Beyond technical skills, we gained experience in communication, sprint planning, and collaborative testing. These are all real-world skills for future software development teams. Future enhancements. Looking ahead, we plan to fully deploy an AI calorie estimator with live feedback entry metrics. We plan to add interactive charts showing daily and weekly progress trends. We plan to build a progress sharing feature where users can compare goals with friends. And lastly, we could expand this to a mobile app so that this is very easy to use from your mobile device. Ultimately, Diet Tracker is more than a class project. It's a foundation for a scalable, ethical, and human-centered health technology. Thank you so much for listening. We're happy to take any questions. Have a great day.